We are going to talk about circles today. Specifically, we want to know the difference between the circumference of a circle and the area of a circle. So we're going to talk about those things first on this first page. As I'm writing down, I want you to copy down what I have as well. Feel free to pause this video at any time if I'm going too quickly for you, and you can start it back up when you're ready. So we're going to first start with our formulas. Anytime there's a circle problem and it's asking you about circumference or area, we want to reference our 7th grade formula chart. And you'll notice on the formula side we have circumference in its own section and area in its own section. So they are two separate things. Circle is listed in both of them. Circumference is the distance around the circle, and to find it we're going to use this formula here, C equals pi d. And for area of a circle, it has its own formula down here underneath area, and it is A equals pi r squared. And so this R and this D, these are vocabulary words. They're parts of a circle, so let's make sure we know the parts of a circle before we move on, because we're going to be referencing the R, which is your radius, and D, which is your diameter. So for R, being the radius, it starts in the middle of a circle and it's a straight line that goes out to the edge of a circle. For a diameter is a straight line that starts on one edge of the circle, goes through the center of the circle, out to the other edge of the circle. We have another part of the circle that is called a chord, which you won't necessarily need to know today, but basically it's a line that looks kind of like a diameter, except it doesn't go through the center of the circle, as you can see. And then the last thing is circumference, and I'm going to write it all the way around the circle, because circumference is the distance all the way around there. Okay, so however you want to show that, circumference is the distance all the way around that shape. Let's start with our circumference examples. You'll notice on one of them we gave you the radius, and one of them we give you the diameter. Anytime a circle gives me the radius, and I know my formula is pi d, I need to find the diameter as well. So if I know on this first one that radius is 4.5 meters, to find the diameter, that means I have two of these. So if I continued 4.5 and then did 4.5 again, that would be two 4.5s. If you add those together, we get 9 meters. And so then we're able to plug it into our formula for circumference. C equals pi times diameter. And so C equals, I'm going to leave pi as a symbol for right now. Pi times my diameter is 9. And so if we were going to leave these in terms of pi, my answer would be C equals 9 pi. If on the STAR test you get to a question like this and you look at your answer choices and they're actually in decimal form, then we're going to need to come over here and do one more step, which is to actually plug in the pi value, which is 3.14, and we'll write that up here just so we remember. Okay, so we're going to stack 3.14 and multiply it by 9. 9 times 4 is 36. 9 times 1 is 9, plus 3 is 12. 9 times 3 is 27, plus 1 is 28. And then we go back up in our problem, double check to see how many decimal places we have. In this case, we have 2, so my answer should match that with 2. And so C could also be represented as 28.26 meters. Either one of these answers would be acceptable. You just have to pay attention to what they're asking you to do. If they are allowing you to leave it in terms of pi, you could stop at this step. If not, go ahead and multiply that diameter by pi. On this example here, we are given the line that goes all the way through the circle. So this is your diameter here. So if the diameter is 16 meters, then we're ready to plug that right in to our formula, C equals pi d. These are multiplied together. So C equals pi times 16. And again, if we're able to leave it in terms of pi, we would say C is equal to 16 pi. If we looked at our answer choices and they're going to have us go ahead and find a decimal, so we're going to come over here and stack it and multiply. So 3.14 times 16. So 6 times 4 is 24. And then 6 times 1 is 6 plus 2 is 8. 6 times 3 is 18. Second row of multiplication, put that 0 in there and we're going to go with the 1. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Go ahead and add those up. 4 plus 0 is 4. 8 plus 4 is 12. 8 plus 1 is 9, plus 1 more is 10. And 3 plus 2 is 5. Again, we want to check back and make sure we've put our decimal where it's supposed to be. So there's 2 decimal places, and there's going to be 2 in my answer as well. So C on this one could also be 50 and 24 hundredths, and my unit is meters again. So that is for circumference. So you're able to find circumference using radius if you double it, or diameter just using that number to plug it in. Let's move on to area. Again, area, from our formula chart, we're using a brand new formula. You cannot use this formula to find area. This finds circumference. You must use this formula to find area, or else we're going to get it wrong. So, with the new formula, A equals pi r squared, this time we're looking for the radius. Up here we use the diameter, but on area we want to find radius. And so in this picture, it in fact gives us the radius. So if my radius is 8, I'm ready to just plug it right in here. And so my formula looks like this. A equals pi times, my radius was 8, and then the exponent squared belongs to the 8. And we're going to follow PEMDAS. Okay, no parentheses, but we are going to have to do these exponents first. So we want to multiply 8 by itself. So 8 times 8 is 64. And so A is equal to pi times 64. At this point, you could leave it in terms of pi. So A equals 64 pi. If they have you go ahead and find the final answer, then you would do 3.14 times 64, and you would multiply that out. So I'm going to assume that we would be able to multiply that out if we finished it up. Let's go ahead and move on to this one. You'll notice this circle gives me the line that goes all the way through. So this is actually the diameter. So if the diameter is 4.2, think about how we could find the radius. Okay, keep in mind the radius just goes from the middle out. And so if you agree, we could say that the radius is half of this distance. And so if we take half of 4.2, we get 2.1. And so we're going to get to plug in 2.1 to our formula. So A equals pi r squared. Plug in 2.1, so A equals pi times 2.1 squared. Again, we're going to use PEMDAS and solve these exponents first, which is just times itself. So if you'll stack 2.1 times 2.1 and solve that for me. Okay, and again, we look for our decimal points, and there are 2 of them. And so we still have pi times my new answer, 4.41. And again, we can leave it in terms of pi. 4.41 pi would be the area. Now again, if necessary, we would need to take this one step further and say 4.41 times 3.14. But again, I'm going to assume that we know how to multiply, so I'll leave it just like that. Just keep in mind this is the exact same thing as this. This right here, 64 pi, is the same thing as 64 times pi. And so we can always just take it one step further and solve these out. And so knowing this, what do you think is the biggest difference between circumference of a circle and the area of a circle? So the circumference would be the distance around that circle. So starting here, walking all the way around that shape. If you straightened it out, if you just put a piece of thread going like this around that circle, you could straighten it out to a straight line and actually measure how long that distance is. Okay, with area of a circle means that you are covering the circle completely. Okay, maybe the problem is talking about covering it with tiles or pavers or dirt. Sometimes they have us, say that we're planting plants and we need to fill in the flower bed, so we'd be covering it with dirt. So this is area. Area is inside the circle. Circumference is the distance around the circle. And so my units for circumference could be measured with a ruler. So things like meters or feet or inches. For area, it's measured with square units, like these tiles. And so this would be square meters or square feet or square inches. So back up here, we had just meters for our units. Down here, if we had actually multiplied these out, your answer would be in meters squared. So you would want to make sure once you multiplied this that meters squared, since its area, is on your answer. Okay, let's go to the next page and let's start solving some of them. Describe pi. We kind of already did that on the other side. If you want to repeat and write 3.14 again, you can. And if you remember, if y'all did the M&M activity in your classroom, we found out that the circumference divided by the diameter is also pi. So you want to keep those two things in mind. All right, my first example says a salad plate has a circumference of 12.56 inches. What is the diameter? So we're looking for D. So given circumference, if we know circumference is pi d, again, we can find that on our formula chart. We know that circumference right here, they're telling me that C is 12.56. And so I'm actually able to plug this value in for C. So 12.56 equals pi times my variable, my diameter, which I don't know. And so if we're looking for an unknown here, we can treat this just like an equation. And so I'm going to draw my balance line. And again, I want to get D by itself. And so attached to it is times pi. So to get rid of that, we're going to do the inverse operation, which is division. And we're going to divide by pi. And so when we divide pi by pi, we get 1. So we're left with the D over here. And then we're going to have to go ahead and solve this out. 12.56 divided by pi, which we know is 3.14. We cannot divide by something with decimals, and so we have to move it over 2 times, which moves this one over 2 times as well. And so I have to kind of guess here because it doesn't go into 1 or 2 or 125. And so I'm going to kind of estimate how many times we think 314 is going to fit into 1,256. And I'm going to guess 4 times, and it actually goes in evenly. And so my diameter is 4 inches. How did I know it was inches? Because it was inches in my problem. So I'm going to keep it inches. Then it says, okay, well, if the diameter is 4, what's the radius? Well, we know on a circle, if the diameter is 4, then half of that would be my radius. So my radius would be 2 inches. What is the area of the circle that is not shaded? and we're going to use our ruler. If you remember on the benchmark, they had you use your ruler, and so we want to make sure that we're really practicing that to make sure that we are doing these accurately. So you want to try to find the center of the circle, and since we're finding area, area formula is pi r squared, and so I need the radius in order to find the area. And so I'm going to draw a little radius here so I can measure it. And then you're going to want to grab a formula chart. So if you didn't grab one as you came in, you might want to hit pause and go grab one. But we're going to use the inches because it's asking me to measure to the nearest ½ inch. So we're going to find the inches on our formula chart. And I'm going to first measure the radius of the circle here. And since we're going to the ½ inch, sorry for the glare, but we have about 1½ inches right here that the radius is. Okay, and then we have the rectangle in the middle. And so to find area of a rectangle, again, you could use your formula chart. It's right here, base times height. Okay, so if I'm measuring this rectangle, I get 2 inches as my base. And line it up here. And really, it could go either way. It could either go to 2 or 2.5. We'll make it easy. We'll go down to 2. And so the area of this shape in the middle is 4 square inches. Remember, area is squared units. Okay, but that's not the question. The question is, what is the area of the circle that is not shaded? So we're going to take this area out of the area of the circle. So that's what we've got to find over here. And so A equals pi times 1.5 squared. Again, squared means times itself. And so 1.5 times 1.5. We're going to multiply this out. So we're going to multiply my answer for 1.15, which was 2.25, times 3.14. And you would stack it and multiply. But for what we're doing today, I'm going to speed this process up because I know you want some homework time today to work on your circle practice. So I'm going to go ahead and multiply these for you, but we'll pretend like we multiplied those together. But you get the area of 7.065 square inches. Okay, so if you had stacked those and multiplied, you would get this area for the whole circle. This is if everything inside of here was shaded in, but it's not. They're asking me what is not shaded. And so this is everything inside the circle. If we take out this shape in the middle, which was 4 square inches, to take out in math means subtract. And so I'm going to subtract these areas from each other. 4 is a whole number, so it needs to line up under 7. So we have 7.065, which was my area of my circle, and then we're going to subtract 4. And so we end up with 3.065. And so the area of the not shaded is 3.065, and it is still square inches. More than likely, if this was a multiple choice question, they would have probably rounded either to the hundredths place or to the tenths place, possibly. So if it was to the hundredths place, you might see 3.0, this 5 makes the 6 go up, so 7. Or if they went all the way to the tenths place, this 6 makes the 0 go up to 1. So really any of these answers would have been acceptable depending on how they wanted you to round that. Okay, moving on. On this page, we're talking about semicircles and quarter circles. The first part we're going to talk about is the circumference. So still we're talking about the distance around these shapes. And then we will move on to area, and then we're done. So y'all stick with me. We're almost there. Circumference of a semicircle. We're still going to find the distance on this curved edge, and if you agree with me, we can say that this is half of a full circle circumference. And so if we know a full circle circumference, the formula from our formula chart is pi d, then the circumference, this curved edge here, for a semicircle would be pi d divided by 2. But that only gets me around the curved edge, and so that gives me this distance here, but that doesn't make it all the way around the shape. To make it all the way back to where we started, we're going to have to add this distance here. And again, if this was a full circle, this line right here would be the diameter, and so we're going to say we're going to add the diameter at the very end. Okay, this portion gives me the curved edge, and then we're going to add the diameter to get all the way around the shape. So the diameter again is 10, so I'm going to plug in 10 here and 10 here. And so it looks like this. C equals pi times 10 divided by 2 plus 10. Okay, try to simplify this if you can. Look and see if 10 can be divided by 2, and I know it can. 10 divided by 2 is 5. And so we can actually write this as 5 pi, because this is 5, and then times pi is 5 pi, plus 10. If you were able to leave it in terms of pi, you would be done at that point. You can't go any further. Or if they wanted the actual decimal answer, we're going to use PEMDAS and go ahead and multiply here, and then add 10. So we're going to bring that over here. So 5 times pi is 5 times 3.14. So 5 times 4 is 20, 5 times 1 is 5, plus 2 is 7, 5 times 3 is 15, and we have 2 decimal places here. And so we are going to put the decimal right there. And then we're going to still need to add 10. So if I say 15.7 plus 10, 10 is a whole number, and so it needs to line up under the 15 here. And so we add these together, and we end up with 25.7, and since it's circumference, it's a distance, walking around this distance is feet. It is not squared because it's still dealing with perimeter, still dealing with circumference. So either one of these answers would be acceptable. This is the same as this. If I was going to find the perimeter of a quarter circle, again, the curved edge is part of a full circle circumference. So again, we know circumference is pi times the diameter, but this is a quarter circle, so this is 1/4 of that. So we're going to divide it by 4. Okay, this is like the center of the circle. You can kind of picture it finishing out here. Okay, so if that's the center of the circle, this distance right here would not be the diameter. This would actually be the radius. But to get back up to where we started, we would have to add in the radius and the radius again. Well, if I have 2 radius, then I have a diameter that I'm adding back, because radius plus radius is a diameter. Okay, so if we add radius plus radius, we are adding a diameter as well. And so you can kind of see some similarities between these two. Pi d divided by 2, that's half of the curve, plus the diameter to get back. This one is 1/4 of the curve, so pi d divided by 4, still adding a diameter to get back. The diameter here is not 5. That's a common mistake I could see somebody making. If the radius is 5, remember the diameter would be double that. So 5 times 2 is 10. So again, I'm going to plug in 10 here. So we get C equals pi times 10 divided by 4 plus 10. We want to try and see if we can simplify this. 10 is not divisible by 4, so really that doesn't help me. but 10 and 4 can both be reduced by 2. And so I'm going to do that. So 10 by 2 becomes 5, and 4 by 2 becomes 2. And so I'm going to rewrite this over here. It now looks like this: pi times 5 divided by 2 plus 10. And what that does, it just gives me some smaller numbers to deal with here. And so I'm going to use PEMDAS, and I'm going to multiply first, then divide by 2, and then add. So pi 3.14 times 5. Again, we did that up here, so we can just kind of copy our answer. Okay, so 15.7. And we're going to say that's my numerator plus 10. Still, we need to divide this here. So 15.7 divided by 2. So 2 goes into 15s 7 times, which gets me 14. I'm going to subtract and bring down 2 into 17. That's going to go in 8 times. Notice I brought my decimals straight up. 8 times 2 is 16. Again, I'm going to subtract, and when I go to bring down, there's nothing, so I'm going to add a 0. And so 2 into 10 is now 5. And so if we were going to continue this here, 15.7 divided by 2, we just solved that, is 7.85. And then we're going to add 10. Again, 10 is a whole number, so it's going to be added to the 7. And we finish out with 17.85, and this time it is centimeters. Okay, last section is area, and area is a little bit quicker because you do not have to add anything back. It's just you're taking an area of a circle and you're chopping it in half. So it says the window shown is in the shape of a semicircle. You want to cover it with fabric. How much fabric do you need? Again, if you're covering it, that is area. And so area equals pi r squared. If we were talking about a full circle, again, you can find this on your formula chart if you ever forget it. But we don't have a full circle, we have half of that. And so we're going to divide it by 2. We need the radius here. This gives me the diameter is 10. So my radius is 5. I'm going to plug 5 in for r, so it looks like this. A equals pi times 5 squared divided by 2. PEMDAS tells me that I have to do my exponents first, and so 5 squared is 5 times itself, so that's 25, still times pi, and then divide that by 2. So I'm going to go ahead and multiply these two numbers together. So 3.14 times 25 and sped that up for y'all a little bit. I know that's faster than you can write, but we get 78.5, and then I need to divide that by 2 because again we just have half of a circle. And so 78.5 divided by 2. And we finish out with 39.25 feet squared. And again, why is it squared? Because we are covering it. Area is always squared units. Last one. This is a quarter circle, so we are dividing the area of a full circle by 4. This time it gives me the radius is 5, because remember this is like the center of the circle. And so we are finding the radius here and plugging it in. And so it looks like this: pi times 5 squared divided by 4. This is looking similar to this up here, so we can kind of use that as a reference. We know 5 squared is 25. And so we get 25 times pi divided by 4. So I already multiplied 25 times pi up here, so I'm just going to use that same number kind of as a shortcut here. But instead of dividing by 2 for a semicircle, I have to divide it by 4. And so 78.5 in the house, 4 outside, and bring that decimal straight up. So 4 goes into 7 one time. 4 goes into 38 9 times. Had to think about that one a second. 4 goes into 25 6 times. I'm running out of room. I'm going to subtract, sorry guys, and get 10. 4 goes into 10 2 times, and then we would subtract again, and we get 5 times. And more than likely, if this were on the STAR test, we would they would ask us to probably round it off to the tenths place. And so once you got to this 2, you would realize it doesn't really affect the 6. And so you could probably finish it out with 19.6 square centimeters. It just kind of depends on the question. If it's asking you to round, then you would want to round, but if not, then they want this full answer here. So really either one of these answers would be acceptable, unless of course it's multiple choice, and then you would want to go with what they're doing. And that's it. So your assignment today is to finish out the packet starting with number 1. Good luck. Make sure you have that formula chart to help you out.